Hi, this is Larry Stewart with ForConstructionPros.com. I'm at IQ in the Ditch Witch booth with Richard Levings, who's the trenchless product manager. Richard, why don't you tell us how Ditch Witch is approaching rock today?
Okay, Larry. There's a lot of different ways that people over the years have handled rock and directional drilling, and rock and directional drilling used to be very difficult, but many innovations have come along, and at Ditch Witch we try to be very innovative about the way we approach issues in the industry. And so we have a three-tiered effect, if you will, on the way we approach rock. With a standard directional drill, we have what we call the Tri-Hawk. And that Tri-Hawk is a very common name in the industry, and it's been developed and is very effective in chunk rock and really soft kind of rock and rocky conditions. But then when you get into the more serious thing, we about 10, 11, 12 years ago, we developed a system we trade named AllTerrain. And we've made some very good enhancements to the AllTerrain, and it tends to be the industry standard in terms of the smaller directional drills of how people approach rock. And so some of the key things, Larry, that we see with the AllTerrain is your ability to continuously drill. With a directional drill, as you approach rock, it becomes very difficult sometimes to steer. And so with a standard directional drill, you have to stop and you have to carve and you have to sit for sometimes hours at a time trying to steer in that. With the AllTerrain, however, and the continuous drilling process, you basically set the direction you want to go, and it allows you to just continue to drill and make that steer or that direction change all simultaneously. Mm-hmm. And it's been very, very effective, and customers have been very successful with it.
Can you tell us a little bit more about the drill head, or what element in the string allows that steerability?
You bet. And with that, we're using, in most conditions with the AllTerrain, we're using a Tricone bit, which is a rock bit for many industries. So we're attaching a Tricone bit, and it's a roller cone bit, and it's designed obviously to cut rock. And that is attached to a 2-degree bent sub, and that gives you the angle to allow you to do the steering. Okay. And that bit is attached to a center rod or pipe that goes all the way to the drill, and that's a pipe in a pipe. So that center pipe is always rotating that Tricone bit, and that's why you're continuously always drilling. The outer pipe is attached to the 2-degree bent sub, which allows you to do your steering, and that's your direction control. So the outer pipe does nothing more on the pilot board than to steer the drill. You're either going straight or rotating slowly, or you're orientating the bend in that bent sub in the direction that you want to go, and you're parking it in that position, and the inner rod that's affixed to the bit is always drilling. And so you put it in the orientation you want, and you just drill to that point till you steer to where you need to be, and then you just slowly begin to rotate the outer or the directional control piece of it. Now, when we get to the other side, then you take that apparatus off and attach to your normal back reamer, and your outer pipe then drives the reaming process. So it's all integrated and made to work together, and it's been very, very effective.
Well, with that 2-pipe system, are you pumping mud down that center pipe?
Okay, on the smaller one, no. It's a rod, and we're pumping the fluid in the annulus of the outer pipe, between the outer pipe and the center rod. On the larger two, yes, we are. We're pumping it. It's hollow in the center. We're pumping fluid down the center of that inner rod.
So how do you get enough flow with a solid inner rod to properly flush those cuttings out?
Sure, that's not an issue. There's enough annulus there to flow all that you need.
Okay.
On a back ream to be able to pull
on a
those
job
back.
Like that, what would be a typical flow rate?
That's one of the best benefits of the AllTerrain system, because in normal rock drilling with a fluid motor, a mud motor, it's very flow dependent. So you have to flow a lot of flow, and when you get into environmental sensitive areas, oftentimes you get what they call inadvertent returns, if you will, Larry. And that's called frack out. Okay? With the AllTerrains, you greatly reduce your opportunity to frack out or inadvertent returns because you're using about 10 times less fluid
I see.
on that pilot bore. And so we use, on a typical basis, anywhere from 10 to 25 gallons per minute on a pilot drill. And then when you get in the back ream situation, you can get, you know, on the smaller one, you can get 35 to 40 gallons a minute down through there, and that's typically more than enough.
Okay.
And on the larger ones, you can get 120 gallons a minute or so down the inner tube. So
when you're pulling back, you're not necessarily pulling both pipes back, I assume.
well, both pipes are coming back, but you're only utilizing the outer pipe, the torque carrying member, the outer pipe, and then you're just pumping fluid through the inner one. And
you
so
can get 35 gallons per minute down through there with a solid inner stem?
Yes.
Oh, okay.
Yeah.
I see.
Yes.
Okay.
Yeah, 35 to 40 gallons a minute is what is typical.
Okay, I see. How long has it been since Ditch Witch first introduced the all-terrain system?
Okay. Its predecessor, the RS860, we brought to market in 1995. And then the all-terrain as we know it today, we introduced in 2000.
Okay.
So we've got 11 years, almost 12 years of experience in the industry. And it has truly become an industry standard in the smaller drills, below 100,000 pounds. And it's just a fabulous tool in so many different soil conditions. The other benefit, Larry, that I didn't mention was that in the earlier days of directional drilling, we would start a project with the boring arrangement, and we would get into the bore, and you'd get out there so far, and then you'd hit rock and you couldn't steer. So you'd have to pull back, put some kind of a rock apparatus on there, and try to go down there, get your steering, and oftentimes then you'd get to the other side of that rock and you'd be in soil, but that's not really good for soil boring, so you'd have to pull back, change your tool out again, go back in, and do that. The all-terrain was designed to start the bore and finish the bore with the same tool. And that's why, and you're going, in a typical bore, you're going to encounter multiple types and kinds of soil structure. So you may go soil, rock, soil, rock, soil, rock. You may go soil, boulders, cobble, and whatever in that deal. You start the bore with an all-terrain and you finish it with an all-terrain. The other piece of that is that oftentimes people would spend days trying to make their pilot bore, and it may take them 5 attempts to get that done. With an all-terrain, you don't guarantee yourself anything in this business, but with an all-terrain, you can get to the point to where you start the bore and finish the pilot bore on the first attempt. And you usually do that within hours rather than days.
How does that Tricone Head perform in soil?
It does pretty well. We've learned some tricks when using a tricone, because in sticky clays, a tricone is very difficult because it wants to bit ball, if you will, and it would get soil build up on the front. So we just have a few tricks with mud and about keeping that clean, and if you keep it clean, you can just progress right on. And so
does that just increase flows of drill fluid through the stem?
We basically are boosting the fluid, blowing that bit ball off, drilling till it balls again, blow it off.
I see.
And then the other thing that you do is you design your fluid so that you can keep the clay from sticking to the product. So you're putting some additives in to keep it from sticking.
Okay.
Yeah.
Richard, just introduced an all-trade air hammer, I understand. Tell me what that, how that process is different from what you've had in the past, and what purposes it serves.
Sure. Larry, in the industry, over the years, we've obviously always wanted to work in really hard rock, and we've been able to addressed the rock thing through the AllTerrain, have been able to work in places that in the earliest days we didn't think we'd ever be able to do, obviously, but projects have now moved us into those areas where it's extremely hard solid rock. And when I say extremely hard, I'm saying 25,000 psi and above. And so there's been kind of a craze, if you will, of people really wanting to utilize air hammers, downhole tool air hammers that have been present in water wells, oil wells, all manners of mining and whatnot, and they're very productive in hard solid rock. So we have some very inventive customers, and one of them in particular said, you know, we love our AllTerrain, and there are limits to rotary drilling, so why don't we attach a air hammer to our AllTerrain hammer, our AllTerrain system? And they did that and were very successful with it. So they came to us and said, this is what we've done, and so we've now made that available, and it allows us to take the already very productive AllTerrain into that harder rock, and you get the benefits of having an air hammer and steering it and controlling it with an AllTerrain.
Sure.
And so we've chosen a hammer that is water lubricated, so you don't have to have an oiler. You can go into those environmentally sensitive areas, and you've got the hammer that's very adaptive to that. But also we use a hammer that uses what they call a hydrocyclone. And that hydrocyclone means that we can pump a foam and water mixture down in the 3 to 4 gallon range per minute. And the hydrocyclone strips all of that water and foam out of the system right before it goes through the hammer, so you're not slowing down your hammer, but you're getting the proper lubrication, and we're using the foam to clean the hole. So it lets us go farther, it lets us clean the hole better, and at the end of the project you have foam that decomposes and you have a dry material to haul off. So it's a very, very appealing system that is working extremely well. We've been out with it 3 to 4 or 5 months now in the actual marketplace. It's been on the contractor's position for 3 to 4 years now, but we started commercially providing it 3 or 4 months ago, and the success is just amazing.
Well, tell me a little bit about the collaboration with that customer. I mean, how much of what somebody's going to buy today from Ditch Witch is customer design?
We all the time have customers that come up with great ideas, and they approach us, and we will work with them, and if it is something that is truly customizable where we can take it across the board and all customers will benefit from it, we implement it, and we work with that customer on that implementation. And we just believe that the greatest ideas aren't at a manufacturer. The greatest ideas are in the minds of our customers. And I could go through a whole list of things that customers have brought to us that have been very successful in this industry.